So very good day to everybody. This is Computer Communication Networks, and in this today's class we discuss about the various network layer protocols, which is nothing but Internet Protocol, Internet Control Message Protocol, and then Mobile Internet Protocol. Okay. So this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, let me thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students and young researchers. In today's class, we discuss about the various types of network protocols and about the users and benefits. Then we discuss about user datagram protocol and BGP, border gateway protocol. Okay. Then we discuss about dynamic host configuration protocol, then about the simple network management protocol, then about the POP3 and telnet. Okay. We discuss about the various examples of security protocols. Then in the second part of today's class, we discuss about the ICMP, Internet Control Message Protocol. Then in ICMP, we discuss about the source quench message, about the parameter problem, the time exceeded message, and finally the redirection message. Okay. So I will give the invariant work for you in the Google Classroom. Please complete them. As I am telling you once again, 5 invariant works and 1 open-ended project work has to be completed. So at regular intervals, I will be giving you some short videos to discuss the knowledge in our topics. Okay. Right. So whenever you take in the case of network protocols, it is nothing but rules, nothing but regulations, nothing but standards, which is going to compute or maybe govern the data communication between several devices in the network. So it is going to determine what is going to be communicated, how it is going to be communicated, and when it is going to be communicated. So it permits connected or maybe communicated devices to communicate along with each other, irrespective of the internal as well as structural differences. Okay. So there are major 3 categories of protocols. We have communication, management, and then security protocols. Okay. So first we will discuss about communication protocol. So for the entire functioning of the network, we use communication protocols to communicate with each other. So it's not possible to have computer networks without them. Okay. So we'll have the rules, we'll have the formats through which the data is being transferred, and the protocols will be having desired syntax, some semantics, error detection, synchronization, and authentication and security procedures even. Okay. So the example we can consider hypertext transfer protocol. Okay. So it's a layer 7 protocol. Generally for transferring a hypertext between 2 or maybe more systems, you can use HTTP. So HTTP, it works on a client server model. So which means that most of the data which is sharing over the web are done through using the hypertext transfer protocol. Then we have TCP, transmission control protocol. We have the client and the server. So we have the active open. So we have the synchronization segment. You will be getting the synchronization plus acknowledgement. Then you will go with the acknowledgement segment. Okay. So the TCP, you can use it for the reliable stream delivery. Generally for connection purposes, you can use this connection oriented protocol. So between applications, you can establish the connections for sending any data. So you can use the TCP for communication across the networks, maybe like emails, file transfer protocol, or maybe streaming media. You can use the transmission control protocol. Then you have UDP, user datagram protocol. It's actually a connectionless protocol. So it's a basic, but it's having an unreliable message service. So that is the major problem. Other than that, it is fine. Okay. So it adds no flow control, reliability, or maybe error recovery functions. But when reliability is not required, you use a datagram protocol which is just functional. Okay. So maybe if you want faster transmission or maybe multicasting, maybe 2 transmitter and receiver transmit at the same time for multicasting operations, or maybe for broadcasting connections, you can use user datagram protocol. And then we have BGP, border gateway protocol. So it's actually a routing protocol. You can pass the packets through the router, okay, in an independent system. So it is nothing but a network of systems which are connected together by a single organization, okay, and you can connect across different networks. Okay, so it's a routing protocol. So it will be connecting the LAN endpoints and maybe other LANs also it is going to connect with different LANs, with one LAN, with different LANs it is going to connect across each other. Okay. Then you have address resolution protocol, ARP. So maybe to map the logical addresses, okay, to the physical address in the local network, you can use address resolution protocol. So maybe for mapping and maybe maintaining a correlation between logical and maybe physical addresses, you can use the ARP, address resolution protocol caching. Okay, so that is the where the similar items are being stored. Then you have internet protocol. So it's a protocol which data is being sent from one host to another across the internet. So maybe for addressing or maybe routing data packets, you can use internet protocol, and that would definitely reach the destination where you are intended to. Then you have DHCP. Okay, so generally for network management or maybe automating the configuring devices, so you can use dynamic host configuration protocol. So we'll have like different servers. Okay, so 192.168.1.100, 101, 102. So this is how DHCP server is going to connect across different computers. Okay, across the address. Okay, so DHCP server, it is going to automatically assign an IP address and maybe several configuration changes to the devices on a network. So maybe you can communicate across several IP networks. Okay, so maybe like a network transfer protocol or maybe domain name server or maybe TCP, transmission control protocol, or maybe user datagram protocol. You can connect across several services, and that is the advantage of the dynamic host configuration protocol. Then after communication protocols, we'll go with the management protocol. So you can describe the policies, procedures, even maybe for monitoring, for maintaining, and maybe managing the computer network. You can use the management protocol. Okay. So just like communication protocol, you can use for communicating these requirements in order to maintain, okay, or maybe in order to ensure stable communication or connection. Okay. So mainly management protocols you can use for the troubleshooting problems. For example, if the network is not properly established, and for example, your Windows that you try to use will be sending a troubleshooting message. Okay, between the host and the client, it will be establishing the connection. Okay. So the examples would be ICMP, Internet Control Message Protocol. So it's actually a layer 3 protocol that is used by the network devices. You can forward the operational information, and maybe you can forward the error messages even. Okay, so if you, for example, if there is any congestion in the network and you have to report the congestion or maybe network error or maybe diagnostic purposes or maybe timeouts, you can go with the ICMP, Internet Control Message Protocol. So we have SNMP, Simple Network Message Protocol. So maybe you'll have the monitoring server. Okay, so that is being expressed with the case of firewall across the routers even. So maybe through the mobile devices, with the Windows, with the mails, with the apps, with the respect to each of the telemessages that you are going to control, you can use the Simple Network Message Protocol. So it's a layer 7 protocol. You can manage the nodes on an IP network. So here there are three components. We have Simple Network Message Protocol agent, SNMP manager, and the managed device. Okay, so it has the knowledge of the management details. It is going to transfer, or it is going to translate the details into a form which is compatible with the SNMP manager. Okay, so the manager is going to present the data that is required by the SNMP agents, and you can monitor the network glitches, network performance, and you can troubleshoot also. So additionally, it is going for troubleshooting the problems. Okay. Then you have Gopher and then file transfer protocol. Actually, Gopher is a very old protocol and now it is not being used. Okay. So for file retrieving procedures, you can use this protocol. Maybe you can use it for easy management, retrieving, and then searching of the files. So everything are arranged on a remote computer. Okay. Then you have file transfer protocol. So it's a client server protocol. You can move the files to the host computer or maybe from the host computer. You can download the users, you can allow the users to download files even, maybe programs or maybe web pages even, and that is how you can establish a client server connection. Okay, so that you can establish the client server connection as well as you can move the files to and from the host computer. Then you have POP3 and then telnet. Okay, so POP3 generally for mail purposes. Okay, so it's a local mail client. Generally, you can get the mail messages from the remote email server across the TCP IP connection. So here, email service which are hosted by the internet service provider will be using this POP3 protocol to hold and maybe return or maybe receive emails intended for the particular user. Okay, so for sending as well as receiving emails, you should have a email client software maybe to check on the email box, and you can download the emails. Okay, so after the email client is going to download the emails, they are going to generally delete from the service. Okay, so that is for temporary sending of the messages. Then you have telecommunication network or tele network. So it's a protocol telnet which is going to connect the user to the remote computer program. So for remote connectivity, you can use telnet. So it is going to establish connection between the host machine and the remote endpoint. So if you establish a remote session across these computers, then of course telnet is at its best. Then we have security protocols. So here all of them are security protocols like HTTP, telnet, file transfer protocol, simple message transfer protocol, secure socket layer SSL, TCP, transmission control protocol, IP, internet protocol. We have several layers across, okay, like internet layer, transport layer, secure layer, application layer. So every layers will be like, totally there are 7 layers. So out of this one, these are all like security protocols. So as the name implies, it is going to secure the data across the network. Okay, so for example, if there is unauthorized user who attempts to get into the network, okay, or maybe unauthorized network is there to extract and review data, so that is going to prevent them. Okay, so the protocols make sure that no unauthorized devices or maybe users or maybe services can access the network data, and the protocol depends on the encryption procedure to actually secure the data. And these are the examples. We have SSL, secure socket layer. So it's a network security protocol generally for protecting sensitive data and securing the internet connections. So it will be allowing server to server as well as client to server communication. And as I told you earlier, I don't know whether you remember or not, whenever you visit any website, you should check whether it is having a valid SSL certificate. So other than that, if it is not having, means your data is subjected to be open or maybe transparent. Okay, so it is not good. Fine. So the data transferred through the SSL is actually encrypted. So it will be stopping any unauthorized person from accessing it. Okay, and you also have HTTPS, Hypertext Transfer Protocol Secure. So it is the secured version of HTTP. So generally for establishing secure communication between two computers, where one it is going to send the request through the browser and other will be getting the data from the web server. So then you have transport secure layer, transport security layer. So it's actually a security protocol for data security and privacy features even. So everything is dependent on the encryption procedures. So whatever is we are trying to send the data across the network, it will be having the security features even, and definitely it will be checking whether it has been tampered with or not, and maybe it relies on the authentication. So maybe for the encrypted communication between the servers and the web application, maybe like the web browser, so it can be used for encryption of messages, emails, and then voice over IP. So this is the reason, like we have sync and then acknowledgement, and we establish the client key for each of the page that you are going to visit, and it will be establishing the communication for the TSL. Now we move on to the second part, which is nothing but internet control message protocol. So for error control, especially for sending the error as well as control messages, you can use the ICMP. So for reporting errors and management queries, you can use the internet control message protocol. So it's a supporting protocol that is designed to be used by the network devices for sending error messages and maybe operation information also. So the requested service is not available, or maybe the host or maybe the router cannot be reached, means it will be sending a error message and operations information. Right. So this is the ICMP, Internet Control Message Protocol version 4 packet format. We have the type, code, checksum, okay, type is 8-bit, code is 8-bit, checksum is 16-bit, extended header 32-bit, and then payload of variable length. We'll see one by one, okay, and we'll have a source quench message also. So that's a request to decrease the traffic rate for the messages sending to the destination. So when receiving the host actually detects that the rate of sending packets, or maybe the traffic rate is maybe too fast, means it will be sending the source quench message. So if it is the traffic rate is very much high, so it will be sending a source quench message to the source to actually slow down the fastness, or maybe to slow down the pace, so that no packet can be lost. Okay, so maybe you'll have, so from source to destination 1, 2 and 4, 3. Okay, so here if you can actually, there is congestion, means you have to go for slowing down. Okay, so here ICMP is informing to the source that 2 is actually congested, so packet is discarded. So immediately the information is being passed on to. Okay, so maybe if you can slow down the rate, which means that no packet can be lost. So ICMP will take the source IP from the discarded packet, and it will be informing the source once again by the source quench message. So this will actually reduce the speed of the transmission. So the router will be free from the congestion. Okay, so from the source 1, 2, 3, 4, 5 and 6. Okay, so the packet will be discarded. Every information is brought to inform to the source, and it will be the very far distance the congestion is being occurred. So it will be going on across the node, and it will be informing them. Then accordingly, it will reduce the speed of the transmission. So there is parameter problem also. So whenever the packet come to the router, so the calculated header checksum should be equal to the receiver header checksum. Only then the packet is accepted. Okay, so if it is not equal to the received header checksum, which means that there will be parameter problems. Okay, so there will be noise modified IP header, which means that you have to check the checksum. Okay. There is a mismatch packet also that will be dropped by the router. Okay, so ICMP will take the source IP from the discarded packet and will be informing the source by sending the parameter problem message. Okay, so there is time excited message also. So when some fragments are lost in a network, then the holding fragment will be dropped. Then ICMP will take the source IP from the discarded packet, and it will be informing the source about the discarded datagram due to the time to live TTL field, which will be reaching 0 by sending the time exceeded message, which means that after the time it is trying to send the message. So this is the case from source to destination 1, 2, 3 and 4. Here there is link failure, hardware failure, port failure, which means that it has exceeded the time limit. Then you have redirection message. Redirection means if it is unable to transmit, or maybe if there is any delay problem, means it will redirect. Okay, so it will be redirecting the requested data packets which are sent on an alternate route. So the message will be informing the host about its need to update the routing information, which means that it has to take an alternate route, not the direct route, but an alternate route. For example, let us take an example. If the host tries to send data through a router R1, and maybe R1 sends the data to R2, there is a direct way from the host to R2. Okay, so what R1 will do, it will send a redirect message to inform the host that there is a better way or best way to reach the destination directly through R2. Okay, so host, what it does, it sends data packet for the destination directly to R2. Okay, so the R2 will send the original datagram to the destination, and if the datagram contains routing information, which means that message will not be sent, it will be sent across the best route. Okay, so this is the thing. So this is the example. We'll have the host redirect. Okay, so this is 1. Okay, and this is 2. Okay, so across 2, it will be going across like G00. Okay, S00, and across to the 1. Okay, so this is the ICMP redirect. Okay, we'll be having the ICMP redirect verification. So it's a redirect for the host, ICMP redirect for the network has been established even. Then redirect actually works successfully, and the redirect verification also takes step by step. So this is how the redirection takes place. So this is the environment work for you. Physical layer, general description, characteristics, and signaling media types and various topologies. Please complete them in your Google Classroom as soon as possible.